The moon and stars to rule by night. This is our third renewed moon day. And what does it mean, the moon and stars to rule by night? Well, I'm going to share some data that I pulled it together today, and just take a look at it, and we'll go from here. All right, so this is a LunaSolCal app that you can load onto a Windows computer and also an iPhone. I'm not sure about other devices, but this is what I use a lot for determining when our new moon day is going to be for our area here in Cooterville. And again, we live under our own perspective of what we see in the sky, different than everybody else across the earth. So our new moon day is going to start at a earlier time or later time than other folks' new moon day, and we're not going to base it off man's calendar either, or his international dateline. So how I've determined my new moon day, and this is the most simple way, is, of course, the first way is to go out and observe the first time the sun and the moon appear together. As the sun comes up, you still see the moon right before it sets, and that happened today at 6:09 a.m., and the moon set at 6:21 a.m., 12 minutes later. And as you see here, it actually, the moon, this here cannot happen until that moon goes full. So the moon went full on 6:21 and 24. It's an instantaneous going full because the sun and moon are constantly moving. So it's waxing, hits full, and then it goes to waning after that. And you just got to kind of wrap your head around that, because the lights are constantly moving. You're going to have when it goes full, it's just going to stay full for a split second and then go somewhere else. And you can't verify that with your naked eye. In fact, sometimes your naked eye can looks like 3 nights there when you see the moon. It's possibly full. But this is a true way to determine when the rule is happening, is sunrise 6:09 and moonset 6:21, and that's been my go-to for a long time when I can't visually go out and inspect it due to inclement weather or anything. And it's very easy to do. It's very easy to pull up and very easy to check. And there's other devices and other websites you can go to and find out them same times for your area and such. But I'm a fan of the LunaSolCal app, and so it's been good for me. And there's other ones out there. Timeanddate.com is another one. Mooncalc. I think it's mooncalc.org and suncalc.org, or it could be .com. But anyway, there are a couple others. But again, when I see the sun appear here and the moon still in my visual here, then I consider that my new moon day. All right, so this is another part of LunaSolCal app. This gives more information on the sun. So I was looking at twilights here. I was getting up at 4:27 a.m. and taking pictures, but my pictures were so dark you couldn't really tell. I could actually see the sun off in the distance, but my camera's not a good enough nighttime camera to get a shot of the light from the sun at 4:27 a.m. Your nautical twilight started today at 5:05 a.m. and it runs to 5:41, and that's when civil twilight begins at 5:41 all the way to sunrise at 6:09 a.m. So there's some more data that you can go to in your LunaSolCal app. And so I took pictures, and I'm going to show y'all pictures here in a second, so stick around and show you the pics that I got with my camera at these different times. And then also wanted to point out here at 6:09, which was when the sun appeared on the apparent horizon for my area, although I can't really see the sun until about 4 or 5 minutes later because of all the trees and hills back off into the east. So I'm just going to look at this data here, and I know the sun is on a more northerly route right now because it just finished its longest day of the year a couple days ago for here. So it's coming back toward the south now, or moving back toward the eastern area here, and then wintertime it'll go over here. But right now it was more northerly route. So as you see, it's 29 degrees off of east here at 61 degrees. on the azimuth. So I want to keep this degree in mind, and when we look at this next slide here, and this next slide shows 232.8 degrees at the moon. Now, I was 4 minutes off on that time, so there's going to be some fraction of degrees difference here with that 4 minutes of time. But it's not going to be a whole lot. As you can see here, if we took the 232.8 and we take the 61 degrees that the moon was at and subtract it, we get 171.8. So the sun is within 180 degrees of the moon. And when the sun and moon are exactly 100 degrees, no matter which model that you believe in, whether it's a globe model or a flat plane model that Tanya and I believe in, either way, it's when that sun and moon line up opposite of each other by 180 degrees, it goes full. I don't know exactly how that occurs, how it does, but it seems to be electrical that makes that happen. But either way, when it goes less than 180 degrees, that's when we know that's already went full. So our next day, which is today, would have been is our full moon day, or our third month of the year, third renewed moon day of the year. And again, this gives you here when the full went 100% at 6 on the day before at 8:10 p.m. So approximately that's about 10 hours, almost 10 hours before our day began here. Now here's some of the photo data that I took. So this is at 5:06 a.m. This is a minute after nautical twilight was mentioned. So this is during nautical twilight. I enhanced the light in my camera to where I could pick up better here. So this is the moon. This is not the sun. This is the moon at 5:06 a.m. And as you can see, it's off in, this would be in my west-southwesterly. The moon is more on a southerly course. It's like it's on a winter course right now. So it's not up in our sky as long as it is when it's on a more northerly route. And if nobody knows this that's listening, the sun goes between the tropics, twice a year. It goes outside to the south and then comes back and goes all the way to the north. So it does that, once a year it does that. Well, the moon, once a month, it goes between the tropics, south and north, every month. And maybe I'll do a video here soon that will show that and just give you some ideas of how the moon travels and such. But this is at nautical twilight, so this is still dark. I couldn't read a newspaper at this point in time, although the moon is super bright, and I possibly could see some of the words on larger print. A newspaper print probably wouldn't be able to read it at this time. It's just because I've enhanced the light here because it was so dark. I wanted to give for one thing, I wanted to show how much light was coming from the moon that it was casting across on the other side here. So this is a app called Skyview. Skyview has been very helpful in helping me determine what stars are what up in the sky at night. Also, it helps me find the stars in their constellations and such. And as you can see here, the moon is at the beginning of Sagittarius, and it just came out of Scorpio a few days ago. So it's kind of in between the third constellation and the fourth constellation out of the 12 constellations. And because we started our year at a later date, that's why you're already seeing the moon at Sagittarius. Sagittarius is a very large constellation compared to Libra or Scorpio, so it's much larger than them two. So you're going to have a pattern that you can see. And I might still do my 21-year patterns for the first 6 months of the year, like I did for the last the last 7 months of last year. But anyway, I just wanted to show where the moon was. And this moon is not to scale. This is very large. This is not the actual size it would be if you were visualizing it in your field of view or wherever you were at. Okay, so at 5:08, a few minutes later, about 3 minutes into the nautical twilight, again, I enhanced the video, but I just wanted to point out, that's why I enhance it. Look at the brightness. This is coming over the roof of my house. this is the roof of my house, but look how bright it is out on the ground. This is being cast from the moon. And you can see the leaves on the trees are green. It's casting enough light you can get to pick up the green on the trees. And that's because I enhanced my camera. And that's why you see the pixels are so large too. My camera's not built for, it's not a 4K camera or anything like that. It was the best that they had at the time when Tanya and I upgraded our phones. And so it's about 4 years old. And maybe one day we'll upgrade soon. But I thought that was interesting that the moon, even at 5:08 a.m. and the sun's, showing its light from the east, you're getting that. All right, one other thing here, I found it interesting too. Again, I enhanced the video. This is Jupiter here, and I doubled 2 times my zoom on my camera. Again, the pixelation is but Jupiter was so bright up in the eastern sky at 5:12, so that's 7 minutes into the nautical twilight. You could see it very well from where I was. And then if we go to our next one, I took a stellarium map and just wanted to confirm, at that same time at 5:12, Jupiter was where it was at for me and Tanya here. Now here's your civil twilight, 5:41 a.m. and I accidentally snapped this picture, so I wanted to share it just to go to show I make mistakes when I'm out there, and I make mistakes while I do these videos. So I have no idea what that's a picture of. Obviously I hit the button, and anyway, it has some type of image on it. I just don't know what it is. But that's civil twilight started at 5:41, and that's when I took this picture here. And this is 5:42, a minute later. Obviously, I was walking out of the house going toward this is the back side of our home. And this moon is over. This is more of a southerly. This is west, kind of over this way, and it's more on a southerly route. So that's why the moon stayed up less time last night, because it was on a more southerly route, just like the sun when it's on its southerly route in the wintertime for the people that live in the northern hemisphere. Then you got shorter days during that time. So anyway, so you got to understand that both those great lights, they go between, both of them go between the tropics. And anyway, my chicken house out here that one of my great friends helped me with, he'll know, he'll recognize what it is. And anyway, thank you, sir, for all that help. But 5:42 a.m. civil twilight. And now we got 5:42 civil twilight. And again, this is sky view pointed toward that same picture I just took. And again, this is not the scale here. But again, the moon's at the beginning of Sagittarius, and so a pretty good sign for you're going into your 3rd month, with it being at that further at the front side of who they call the archer, I guess you'd say. But anyway, that is not to scale, but just another data I'd like to share here. Now, let's see, we got 3 minutes after civil twilight, and we come back around. I didn't even enhance the light on my camera now, and as you can see, you're getting enough light that you can see the color on the trees, the color of the grass. Still, the sun has not appeared above the horizon, but it's some good data that if you want to know more about the dome that you live under, go out at these times, at this astronomical twilight, your nautical twilight, your civil twilight times, and then sunrise, and take pictures, and then review them for yourself if you're really trying to pinpoint when your new moon day is. Now this is pointed up towards a star Vega, so at 5:45 I could still see it with my naked eye, but because my camera's not a great camera, and my Canon camera's not even a great light source, I have to really manipulate it to get some of the star shots, and I can only see them when it's dark behind here. So at this point in time, it was already civil twilight. You can read a newspaper at this time, no problem, but Vega, I could still see Vega, so that star was still rolling in the sky, and so was the moon. And Vega's not even one of the brightest stars. Well, it is one of the brightest stars, but it's not in, it's like maybe in the top 10 of all the brightest lights. And I'll look that up and make sure on that. But I know it's not even anywhere close to Sirius. And, of course, your Venus and Mars and Jupiter are much larger and brighter lights, or at least they look larger. Don't know if they might be all the same size. Some are brighter than others. But anyway, this was Vega, but here's a stellarium shot of what I was looking at. And as you can see, at that time, at 5:45, that civil twilight time, you can still see the moon off in the south, or the west, southwest area of my sky. And then here's Vega right here, right here. That's where it was. I don't know what this June Lyrids are, or June Scutids. I don't know if it matters. I couldn't see anything like that. That's just something on the stellarium app that I really don't care to find out any more about. But anyway, I did find it interesting that Vega was still in my visual as far as my naked eye. And I don't have great eyesight, so I have to wear glasses to read. So again, I'm limited in my eyesight, but I could see Vega at 5:45 a.m. Still. So that was 24 minutes before the appearance of the sun in my area. Now, if we got sunrise here, we got 6:10 a.m. And the reason we're not seeing the sun at this point in time is because it's behind, at that angle, it's still behind trees and hills and such, because it looks to me, in our perspective, that it's lower in our trajectory. It's the same amount of distance up in the sky. It's way far away, and we don't actually see it until it pushes through all that and then gets through any of the muck in the atmosphere at that time. But anyway, 6:10 sunrise picture, and as you can see a little bit more of the green on the trees and everything else. It's not as dark as the civil twilight, so it's much brighter now. And then sunrise, 6:12 a.m. This is where the moon was, and of course, again, this is not to scale here. This moon is much larger than it actually is. I would say it would be about that far big, comparing it to what I see out there. But this is just the sky view out, and as you can see, the moon would still. I did a video not long ago where I showed a sky view out, and then I showed an actual picture of the moon where it was after I took that sky view shot, and the moon was well above my horizon here. So anyway, so I know this is definitely not to scale here, and just wanted to provide that just to show where it was to the horizon. As you can see here, it's more on a southwesterly. It's toward the southwestern cardinal point, and your western cardinal point would have been over here. And it's like I say, it's more toward the Tropic of Capricorn right now than it is to the equator, or even further north, Tropic of Cancer. All right, next slide. Again, sunrise. This is 4 minutes later, or actually 5 minutes after, and that's actually when I can start seeing the sun. It's usually about 4 or 5 minutes before I can actually pick it up. So as you can see here on the sky view, I believe this is Venus and Mars here. I didn't really look it up, but I'm pretty sure that's Venus and Mars there. The sun is coming up here on the horizon. As you can see, it's much smaller than the moon shot is. And again, you can see it's more northeasterly than the east over here. I believe this would be east cardinal point. So it's more to the, it's starting to move back toward the southern direction toward, we'll eventually get to fall, where it's lined up in the east, and then it'll go toward the winter time where it's all the way goes to the Tropic of Capricorn. So anyway, there's your sun. Next picture. We got sunrise here, so I could actually get a visual. Probably could have got it at 6:13, about 4 minutes later, but by the time I turned around and got this shot with my camera, that's where it was. And like I say, there's tall trees, there's tall hills. Even though Tanya and I are up on a hill ourselves, there's hills larger than our hill that are out this direction and stuff. So gives us some blocking in there. So maybe one day we'll invest in a drone and fly it up a little bit and get above those hills and stuff and take some shots like that. But until then, this is what I'm sharing here data-wise. Now, Metonic Cycle, take a look at that. I've done some research on this. I've shared some of this on a video before. Metonic Cycle is not a perfect cycle, but the one thing that I have realized the Metonic Cycle does, it allows us to go back 19 years from this date and pretty much have an idea where the sun, moon, and stars are going to be at that point in time. So this is from Britannica, and it says here, Metonic Cycle in chronology, a period of 19 years in which there are 235 lunations or synodic months, after which the moon's phases recur on the same days of the solar year or year of the seasons. The cycle was discovered by Meton, we'll talk about him here in a bit, an Athenian astronomer. Now, if we get a look at Wikipedia, it says the Metonic Cycle, and I won't try that word at all, is a period of almost exactly 19 years after which the lunar phases recur at the same time of the year. So again, 19 years after which the lunar phases recur at the same time of the year, which they do. The recurrence is not perfect, and by precise observation, the Metonic Cycle defined as 235 synodic months is just 2 hours, 4 minutes, and 58 seconds longer than 19 tropical years. So 19 tropical years, it's, 2 hours, 4 minutes, and 58 seconds longer. So, yes, it's not a perfect 19 years. And it wouldn't be. Everybody I believe I've spoken to about what I believe about the days of Hezekiah, and we'll cover a little bit more of that here in a second. But here's what they say about Meton of Athens in Wikipedia. It says he was a Greek mathematician, astronomer, geometer, and engineer who lived in Athens in the 5th century BC. He is best known for calculations involving the eponymous 19-year Metonic Cycle, which he introduced in 432 BC into the lunar solar Attic calendar. Euphronius says that Colonus was Meton's dean. Okay. So, application in traditional calendars, again, this is from Wikipedia, in the Babylonian and Hebrew lunisolar calendars. Now, keep in mind, YaHUaH's calendar is a celestial calendar. It's not only luni and solar, but it's also astral. So it's lunar, solar, astral, which is including the stars. So it's not just the sun and the moon, it's the stars also, is how we determine the beginning of our years, is with the stars. So, and the stars can also give us an idea of what month of the year it is too. But continue on here, it says the years 3, 6, 8, 11, 14, 17, and 19 are the long 13-month years of the Metonic Cycle. Now, of course, these cycles are going to be based off of a dark moon cycle. It's not going to be off a full moon, so keep that in mind too. This cycle forms the basis of the Greek and Hebrew calendars. A 19-year cycle is used for the computation of the date of Easter. Each year there's some more Roman paganism coming into the picture there. The Babylonians applied the 19-year cycle from the late 6th century BC. So the late 6th century BC, which was about 150 years after the days of Hezekiah, the Babylonians applied a 19-year cycle. Okay? According to Livy, the second king of Rome, Numa Pompilius, reigned from 715 to 673 BC. Look over here when Hezekiah, the king of Judah, this was when he was born. He died here, but he reigned all the way to 687. And remember, he was given 15 years to the end, so that would have put the date that sundial event happened at 702 BC. And I've spoken on this several times, that all this evidence seems to point toward a perfect 30-day month back before. And, I asked a good friend today, hey, was there any lunar or solar eclipses mentioned before the days of Hezekiah? At this point in time, I don't know of any. If anybody knows of any, please reach out to me through this channel or through email or text or phone call, and let me know what y'all know. But I don't know of any lunar or solar eclipses that were mentioned until after the days of Hezekiah. So, and if you look at Genesis 7:11 through 8:4, you've got a perfect 5 months of 30-day months over a 5-month period of time. And that's empirically impossible on today's current celestial, what we have above us in the sky. It doesn't happen. It's either a 29 or 30-day month based on where the circuitry of the sun and moon are at the time. All right. So this Numa Pompilus that reigned during these periods of time, he inserted intercalary months in such a way that in the 20th year, the day should fall in the same position of the sun. Again, Rome, they're about Helio, worshiping the sun. And anyway, so it's the same position of the sun, which they had started. As the 20th year takes place 19 years after the first year, this seems to indicate that the Metonic Cycle was applied to Numa's calendar. So again, it looks like they started intercalary months. Why during these years here did they start doing this? Could it be that sundial event? I believe so. And I believe there's enough evidence to show that there was 30-day months in Scripture. Let Elohim be true and every man a liar. And what I see in Genesis 7 to Genesis 8 verifies a 30-day months for me. I don't know who else it verifies for, but I know for sure I am verified in that. And then if you look at 15 years before Hezekiah died, that would have put him in 702 BC. And again, if we go back and slay them, I've done this in my videos before, go back to 702 BC, and you can see on March 21st, which is normally the beginning of what they call spring, or the spring equinox is what they call it. Basically, you can go back March 21st with the algorithm of Stellarium and see that the March 21st would have been the beginning of the year back in 702 BC. So definitely something's changed. And so if a Roman king implemented in the calorie months, so what was they doing before then? Why all of a sudden? Just ask yourself the question, why all of a sudden did they start inserting extra months into the calendar? I say you to go check out some of those videos, and it's not just my videos. There's much information out there about, the original 360-day year. All right, so let's take a look at the Metonic Cycle. So how we're going to do this, we're going to look at today's sunrise and moonset, and we're going to look at when the moon went full. And we're even going to look at solar noon, and we're going to look at the length of the day. So we got 6:09 a.m. today, 1:20 p.m. is going to be solar noon, 14 hours, 20 minutes, 13 seconds is the length of the day, which that was minus 4 seconds from the, I guess, the day before. And let's see, because our longest day of the year happened 2 days ago on the pagan date of June 20th. So that's probably why it says minus 4 seconds. Then we're going to look at moonset 6:21 a.m. and then look here, moon went full yesterday at 8:10 p.m. On our man-made time here. So let's go look at 15 years earlier in 2005. Very little difference, guys. 6:09 a.m. sunrise. Moonset a little bit earlier, so it's 6 minutes different. So 6:21 was this morning, 12 minutes difference. So there's 6 minutes difference. But look here, it's showing that the moon went full, the day before at 11:16 p.m. So that's probably why this moon set at 6:15, because yesterday was 8:10 p.m., but 19 years ago, it was 3 hours later. So that would be why this moon set a little bit earlier, is because this sunrise and moonset times where the moonset is after the sunrise, that won't happen until after this happens. And that only happens when the sun and moon are exactly 180 degrees opposite of each other. And it's instantaneous. So both lights are moving consistently, constantly. You can't you can't really see it unless it's up, you got a solid object and you're viewing either one of them. You can see them move at that time, or zoom them in with a camera and put that's on a tripod and leave it there and just watch them move through your camera viewfinder. But anyway, they're constantly moving. So for full moon, it happens instantly. But my big tell sign, when I don't have the ability to see the sun and the moon, this is my witness here. I look back at these times and I put trust in them, because this happened 19 years ago and it's approximately almost identical. And you can even see the noon time is like 1 minute earlier in the day, and your length of day was like 3 seconds more than it was today. So interesting stuff. Let's go back 19 years from 2005 to 1986. So we got June 22nd, 1986. Look here, same sunrise, 6:09 a.m. A little bit different moon set. Instead of 6:15 like it was in 2005, it's 3 minutes later at 6:18. And as you can see, ours yesterday, full moon went at 8:10 p.m. and then the one 19 years back at 2005 was 11:14 or something like that. And you can see that's why there's probably 3 minutes later on the moon set, because these two things don't happen. This sunrise and moon set after the sunrise don't happen until after that moon goes full. And the only time it goes full is when it's 180 degrees opposite to each other. So guys, this is the data. This is what you need to be looking for. This is that simple. It's that simple. It's this sunrise moon set are very simple. And when that moon shows to go full, you can't tell it. Even with a zoom camera, I've tried to zoom in on it at these specific times that it says it's going to go full, and I haven't even been able to see it. Now, you might be able to see it an hour or two later and see some of the waning portion of the light in whatever quadrant of the moon you're looking at that time. But anyway, this is just showing you that Metonic cycle is fairly accurate, guys. So this is how they're able to determine when our sunrise and moon sets are going to be previous, because there is a cycle to this thing, and that's how the algorithms are figured out, and that's how everything is understood currently. Now, is it the same calendar that it was before the days of Hezekiah? I believe not, but I believe now what we have to do, we have to go out and do our due diligence and go out and visually sight these things in. But if you're living in an area where you can't get a good east or westerly view from where you're at because where you're located, or you've got inclement weather in these are good signs. And again, you can get sunrise and moonset times from other sources. This is just an app that's simple on my phone, and it's easy to pull up and easy to quick reference. So that's why I go to it. So Genesis 1:16 says, and Elohim made two great lights, the greater light to rule the day and the lesser light to rule the night, and the stars. So what's that lesser light to rule the night? Well, we get our cross reference to that. It's the moon and the stars to rule the night. So I saw Vega still ruling the night and the moon still ruling the night after civil twilight. So if civil twilight was a part of the day, then I would assume that I wouldn't have been able to visualize Vega. I wouldn't have been able to get the tiny light that it is. I shouldn't have been able to see it, but it still had enough rule that it was able to overcome the light from the sun at that point in time. So the sun hadn't completely started. So I believe the day begins when we feel the heat from the sun, and then when we feel the heat from the sun, it's when it gets above that horizon, and you can feel the heat of it. And that's where Tanya and I stand right now, and that's where we're going to stay until we can be shown scriptural accounts any different. I'm doing exhaustive research into the word for morning and other words that are have commonality with it and such. So I hope to present that soon. It's been a 3 or 4 week process here. I've been working on it a little bit every other day or so and stuff. So anyway, everybody have a great new moon day, or renewed new moon day. And we're going to give all praise and esteem to YaHUaH, because every time we do these studies, it's just more information is given. And thank you, YaHUaH, for everything that you provide for Tanya and I. Thank you so much for all the people that you put in our lives. Thank you for the people that that we don't even know yet, that you're going to place in front of us, that's going to be a blessing to us and such. So anyway, we give all praise and esteem in your name. Hallelujah, hallelujah indeed. And always remember, somewhere in Texas, you're loved from somebody. Hallelujah.